Welcome to one more revision class, grade 12 Euclidean Geometry. We are paying attention to proportionality and similarity theorems. But let's remind each other that when you're answering examination questions, it's no longer the proportionality theorem or the similarity theorem that matters. It is the whole component of Euclidean geometry, starting with the concepts that we learned in grade 8, angles in a straight line, vertically opposite angles, parallel lines, alternate angles, corresponding angles, co-interior angles, the properties of triangles, the properties of quadrilaterals. We need to know all those things. The midpoint theorem we do in grade 10 and the circles that we do in grade 11. So we are kind of summarizing the whole section of Euclidean geometry, and we need to know everything that has been taught, all the basics. They are absolutely necessary in answering these geometry questions. Now, when you're answering a geometry question, avoid paralyzing your mind by worrying about how to prove the expressions that have been put there and checking how many marks are allocated. It can put your mind in a worrying position, and once you start worrying, you're now operating from your weaker point. A geometry question. Geometry is one of the easiest topics to handle because they always give you hints. Or out of all the theorems that you know, there are hints in the question that can help you determine which particular theorems to apply. Important words are words like the center of the circle, the radius, the diameter, tangent, parallel lines. The moment you see those words, they are definitely connected to theorems, and we can determine using those words which theorems are applicable. Let's have a look at this one here. To start with, I have been given the diameter of the circle. The moment we say RP is the diameter, then you ask yourself, okay, what do I know about the diameter? A diameter subtends a 90-degree angle at the circumference, which means S2 is equal to 90 degrees, or we can say angle in a semicircle. Now we have a 90-degree angle there. Let's carry on and see what else we have. We have the center of the circle. I have combined the center of the circle and point E because I know something about the center of the circle and about the midpoint of a chord. Line from center drawn to midpoint of chord is perpendicular to the chord. That means I can safely say that the angle E1, E2, E3, E4, they are 90 degrees each because line from center drawn to midpoint of chord is perpendicular to the chord. Now look at how interesting this becomes. We have angle A1, which is equal to 90 degrees. We have angle S2, which is also equal to 90 degrees. Now, if you look at the positions of those two angles in relation to line RS and line ON, line RS and line ON, we can safely be reminded about corresponding angles in parallel lines. We can conclude that because of the angle S2 and E1 that are equal, the line ON and the line RS are parallel to each other. Now, immediately we get parallel lines, it means we have more information because parallel lines come with corresponding angles, they come with co-interior angles, they come with alternate angles. Now, look at how this has developed. We have reached here from only two items, the diameter and the center of the circle. Let's look at what other information we have. We are told that NP and NS are tangents. There we ask again, okay, What do we know about tangents? We know three theorems about tangents. We just have to choose which one is applicable to our situation. The first one, the tan chord theorem. The second one is line from center, the radius is perpendicular to the tangent. And the third one is two tangents from the same point are equal to from where they touch to where they touch the circle. And if you look at our diagram, all of those three theorems are applicable. We have two tangents, we have a line from center which is touching the tangent. Now we have a lot of information from the tangents. That is my tangent, and that angle there, S1, is equal to angle P1 because of the tan chord theorem. Then what else do I have? The angle at point P is equal to 90 degrees because the radius is perpendicular to the tangent. Now it goes even further. The angle at P is 90, and we have established P1 to be x. Therefore, we can say that P2 is 90 minus x. Look at angle S3. The line PN and PS are tangents. They are equal to each other. That makes the triangle PNS an isosceles triangle. So P2 and S3 are equal to each other, and we have more information there. Now from here, we are definitely able to calculate N1, to calculate N2 using interior angles of a triangle. In triangle SEN, E3 is equal to 90, S3 is 90 minus x. We can find N1 using interior angles of a triangle. We can also find N1 using angle S1 because N1 and S1, they are corresponding angles since we have parallel lines. That is the development of geometry. You start with the hints that are given in the question, and they will lead you to equal relationships, angles that are there. Now, the next phase is how to put up your information so that you can produce the answer, you can produce the something for the examiners to mark. But otherwise, the analysis of the diagram is what determines the required answer. So here is my angle X coming from interior angles of a triangle. They add up to 90 degrees. N1 and S1 are corresponding angles because RS and ON are parallel to each other. So please practice as far as possible how to identify theorems using the keywords which are in the description that has been provided by that particular question. The moment you do that, you definitely are able to answer the question. If you start by looking at the bottom there, trying to figure that out, then it's like solving a puzzle without the pieces. There are very high chances that you won't be able to make it. You start by putting together the information, labeling the diagram, figuring out which theorems are applicable according to the description that the question is given you. Then your question can be answered. Now that we have put our information together, we know what we are dealing with. We can now start answering the question. Number 5.2, 5.1, determine with reasons the angles that are equal to x. We have done that already. We have angle P1 and angle S1. They are equal to each other because of the tan chord theorem. So the angle here at this point and the angle S1 at that point, they are equal using the tan chord theorem. This line is the tangent, so this angle here is the angle between the tangent and the chord. What else do we know? We have OPN. Now, if you look at the line from RPN, this line, this whole angle at this point here, this is equal to 90 degrees because the radius is perpendicular to the tangent. Then we can therefore find P2 by subtracting 90 minus x. P1 is x, but the whole angle is 90. Therefore, P2 is equal to 90 degrees minus x. Then we have angle E4. E4 is equal to x. We are getting this from line from center drawn to midpoint of chord is perpendicular to the chord. So this line here from E to S and from P to E, they are equal to each other. Therefore, angle E4 is equal to 90. If E4 is 90, look at triangle PEN, PEN, triangle PEN. We can find N2 using interior angles in a triangle. They add up to 180 degrees. So that will give us the value of N2. N2 is equal to X. Now, N1 we have already mentioned. N1 is equal to X because of corresponding angles. N1 and S1 are exactly the same. So in this question, your three angles that are equal to X, N1 is equal to X, N2 is equal to X, and P1 is also equal to X. And that answers number 5.1. Now, answering the question becomes easier if the information is provided and we have been able to identify which theorems are applicable in that particular question. All right. Right, let's look at question number 5.2.1. We want to show that triangle SEN and triangle OPN are similar to each other. The way to show that two triangles are similar to each other is to show that the two triangles, their corresponding angles are equal to each other, or we have to show that their sides are in equal proportion. Their sides are in proportion. It means if you divide the sides of one triangle divided by the sides of the next triangle, you must get equivalent fractions. Because we have already put information together, it's now easier to show that these two triangles are really similar to each other. Now, triangle SEN, triangle SEN. So the triangle SEN, at point S, there is angle S3, just to notice that one. Then at E, there is E3, and N, there is N1. Then in triangle OPN, O is O1, and at P is the whole angle P, and N is N2. So what we need to do is to show that the angle S3 in the first triangle and O1, they are equal to each other. Then the angle at point SE and the angle at point P are also equal to each other. So we need to show S3 and O1, then E3 and angle P. They are equal to each other. If we do that, then we have managed. Now let's look here. O1 in the triangle OPN, N2 equals to X. Angle P is equal to 90. So we can find O1 using interior angles in a triangle. They add up to 180. And that will give us the value of angle O1 is 90 minus X. S3 is equal to 90 minus X. We have already calculated that one. So that means angle S3 and angle O1 are equal to each other. We have got the first angle. If you look at angle E3, it's 90 degrees. The angle at P is also 90 degrees. That means the two are equal to each other. Now, the third angles of the triangle, they become equal because angles in a triangle add up to 180. Once we prove two pairs of angles, the third one will become equal because angles in a triangle add up to 180. And that means the triangle SEN is similar to triangle OPN. And your question has been answered. So once again, if you put up information together in your diagram, if you identify the theorems applicable, it becomes easier to put up the information and get the answer required. Question number 5.2.2. We need to prove that Pn squared is equal to En multiplied by On for 3 marks. Now this one must not be something that gives us a headache. In 5.2.1, we proved that triangles SEN and triangle OPN are similar to each other. And that is where the answer is going to come from. If two triangles are similar to each other, it follows that the sides of the triangles are in the same proportion. So if I divide SE divided by OP, then I divide EN divided by PN, and I divide SN divided by ON. The answer that I get, the fractions must be exactly the same. That is the concept of similarity. If two triangles are similar, the sides of the triangles are in the same proportion. If you divide one side of the triangle by the other side by the side of the next triangle, the fractions that you create are equivalent to each other. So in this case, En divided by Pn, I divided the second letter to the third letter, that's En, and the second letter to the third letter in the next triangle. The answer is the same as Sn over On. This is coming from the similar triangles. Then from there, we cross multiply this expression. If we multiply En multiplied by On and we multiply Pn by Sn, we produce Pn times Sn is equal to En multiplied by On. Now, let's notice from the given information that we have two tangents. We have highlighted this one in the beginning, right here, where it says NS and NP are tangents. So that means line PN at this point and line SN, they are equal to each other because the tangents from same point are equal from where they touch to where they touch the second. So we now remove this Sn here and replace it with the Pn such that Pn times Sn becomes Pn times Pn, which is equal to Pn squared. So Pn squared will now equal to En multiplied by On, and that completes the answer for this question. We have been able to prove that Pn squared is equal to En multiplied by On. So once again, if we start by looking at that expression, then we can paralyze our mind with fear, thinking that is something that cannot be done. So the key part in answering a geometry question is to make sure you have identified the theorems which are applicable in that particular question and then put up your information together to create the answer required. All right. Question number 5.3.1. 5.3.1. We want to prove that PE squared is equal to OE plus OE multiplied by EN. Now, this kind of expressions, the moment you say this, start thinking immediately about similar triangles. There are definitely triangles that are similar that have produced this expression. The question we may want to ask is, which triangles are similar? where did they get this expression from? From which two triangles that are similar? So we can use the lettering of the expression PE. If you look at PE, this side here from P to E, then we have got OE from O to E. It makes sense to see that the triangle, one of the triangles here, is a POE. Then you look at the next side, which is here, is EN. From E to N, we're looking at that line. So basically, we can say that the two triangles that are similar is triangle POE and triangle NPE. Now, once you figure out which triangles are possibly similar, the next thing is to prove the two triangles. Now, if you look at our expression, triangle POE in triangle POE, the angle at P is P1, the angle at O is O1, and the angle at E is also E1. Then if you look at triangle NPE, the angle at N is N2, the angle at P is P2, and the angle at E is E4. Those are the angles in the two triangles. Now we need to show that these two triangles are similar. Similarity means you prove that the angles in one triangle are equal to the angles in the next triangle. Now if you look at the first angle, which is P1, compared to the first angle in the next triangle, which is N2. In our diagram, P1 is here, is equal to x, and N2 is here, it is also equal to x. So the first two angles are equal to each other. We have already established this from the previous calculations. If we also look at the angle at E1 versus the angle at E4, we have established that E1 and E4, these angles are equal to 90 degrees since the chord P is divided into SE and PE equally. Line from center drawn to midpoint of chord is perpendicular to the chord. So that means the angle E1, E2, E3, E4, they are all 90 degrees each. We have already completed the proof because once we get two pairs of angles that are equal, it means we have similar triangles because the third angles are equal due to angles in a triangle add up to 180. Now going forward, P1 and N2 are equal. We have explained that one is proven. Then E1 and E4 are equal to 90 degrees each. We have also proved that one. Then the third one, O1 and P2, they are equal. Sum of angles in a triangle add up to 180 degrees. Now that we have got three angles that are equal to each other, three pairs of angles, it follows that triangle POE and triangle NPE are similar to each other because they have equal corresponding angles. Then we make conclusions now. If two triangles are similar, it follows that if you divide the first two letters, that's one side, over the next two letters, you get one fraction. Now, the fraction that you produce there is exactly the same as dividing the second letter to the third letter, that's another side, over the second letter to the third letter, that's another side. The fraction that you get there is equal also to a third fraction, which is the outside letters PE divided by NE. The fractions there will be equivalent fractions. And once you get your equivalent fractions, then you can work around them to produce the relationship or the expression that is required. So in our case, we've got PE squared, which means PE has been multiplied by PE. Therefore, I chose PE, this side from P to E, divided by NE. The position of letters must be the same in each case. So P to E divided by N to E. That creates one fraction. This is equal to OE. OE is these two here, O to E divided by P to E. Those are my two fractions. Then I cross multiply PE times PE and I multiply NE times OE. It will give me PE squared is equal to OE multiplied by EN. By doing that, my expression has been proved, the question has been answered. So this is not difficult if you can just figure out which two triangles did they use to create this expression. Find those two triangles, prove that they are similar to each other, and once you prove that they are similar to each other, you can then produce this expression by cross multiplication, and then you get your answer as required. That is about 5.3.1. We are all good, full marks, no stress about this one. All good if you just follow those steps. Right, question number 5.3.2. The question says, hence show that Pn squared over Pe squared is equal to 2 times On divided by Rs. Now, if we see, if a question says to you, hence this word here, hence show that, the word hence, it means our answer is basically going to develop from the previous relationships or from the previous calculations that we have already done. And we need to find the value of Pn squared. So Pn squared, you can link this to number 5.2.2, where we have determined the value of Pn squared as En multiplied by On. Then the bottom part has got Pe squared. We can link Pe squared to number 5.3.2, where we established that Pe squared is equal to Oe multiplied by En. It therefore means Pn squared divided by Pe squared is equal to En times On divided by Oe multiplied by En. And in this expression, we can divide En divided by En, and that will take us to Pn squared over Pe squared is equal to On divided by Oe. Then very much important now, from our previous discussions, we have OR, this is the radius of the circle. We also have got OP, that is the radius of the circle. It follows that OP and OR are equal to each other. Then we are told that E is the midpoint of line PS. We have already discussed this. It therefore means the line SE is equal to line EP. Then we have the line OE, which we established long back that it is parallel to line RS. Now consider triangle RSP, triangle RSP, triangle RSP. We have a line inside the triangle which is dividing the sides equally, and it is parallel to 1/3 of the triangle. This gives us the midpoint theorem. If OA is equal to A, for example, then RS is equal to 2 times A. That is the midpoint theorem. So what it means for us is that if you multiply 2 multiplied by the line OE, then the answer that we get there must equal to the line RS. This is according to the midpoint theorem. Then from here, we can divide this side by 2 and also divide this side by 2. That will give us the value of OE. So we can say the value of OE is equal to RS divided by 2, or we can say it is equal to 1/2, which is half of RS. And please take note, this is coming from the midpoint theorem. So what does it mean for us? It means in this expression, we take out this OE and replace it with the half of RS because the two are equal from the midpoint theorem. So now we have got Pn squared over Pe squared is equal to On over half of Rs. Now, On here, there is 1 here, basic algebra. If there is no coefficient, it basically means the coefficient is 1. So in this case, we can now divide 1 divided by 1/2. The answer is equal to 2. That's how we end up getting 2 times On in the numerator, which is equal to the given expression. So basically Pn squared over Pe squared is equal to 2 times On divided by Rs. And that gives me the answer for this particular question. So that is my answer for this question. I have proved number 5.3.2. Right, 448. 448 minus 1. 448 60 times 4 equals plus 48 equals 288. All right, we have answered the whole question from 5.1 to 5.4. A quick look at the theorems that we have applied. It's very much important to take notice that when you are reading a geometry question, concentrate on the hints that are in the question. Read to understand what they are describing so that you may be able to determine which theorems are applicable in that particular question. So here we have used the diameter of the circle. We know that the diameter subtends an angle of 90 degrees, or we can say angle in a semicircle is equal to 90 degrees. And that assisted us in determining the angle S2, which is equal to 90 degrees. Then after that, we noticed the center of the circle. The center is connected to a number of theorems. So in this case, we combined the center of the circle plus E is the midpoint of line PS. So we were able to notice that the center of the circle, the line ON is a line coming from the center of the circle, and that line is dividing the chords into two equal parts. It's written that E is the midpoint. So that means the angle at point E is equal to 90 degrees. Then that grew more to say that if the angle at point E is 90 degrees, so this angle here is 90 degrees, and we also figured out that the angle at S1 is equal to 90 degrees. Now this reminded us of our corresponding angles, making the line ON and the line RS parallel to each other. Then it brought in the idea of corresponding angles. So this angle S1 is corresponding to angle N1. Therefore, N1 is also equal to X. Then we also were able to identify another set of information provided, that's NP and NS. Those are tangents. We remember immediately the tan chord theorem. It gives us angle S1 being equal to angle N1 by the tan chord theorem. So this angle here is equal to that angle there, and the reason for that one is tan chord theorem. So S1 is equal to angle N1, and S1 is also equal to angle P1. So now we have got X here, we have got X here. That means out of the three angles that are required by this question, we have been able to figure out two so far, just by doing an analysis of the diagram and putting the information that is provided. So those are the sets of information we've used. Then after noticing that there is an angle of 90 degrees at point E1, E2, and 3, 4, we also notice that there is an angle of 90 degrees at point P, because in a triangle, the radius in a circle, the radius and the tangent are perpendicular to each other. So at point P, the angle P is divided into two. One is equal to X. The entire angle is 90. Therefore, P2 is equal to 90 minus X. We also notice that the line PN is equal to the line SN by tangents from same point equal from where they touch to where they touch the circle. That makes the angle S3 and the angle P2 equal to each other, because triangle PSN is an isosceles triangle. That is also one of the ideas that came through. Then other angles can be calculated using interior angles near triangle add up to 180. Then in answering the question, we notice that the first expression is similarity. You are comparing corresponding angles. The angle in the first letter S compared to the angle in the first letter. If this angle is equal to that, then we've got one pair. Then we check the next one, which is the second letter, the second vertex of the triangle, that is angle at E and the angle at P. It is necessary to notice that in triangle SEN, it might be necessary to specify the angles. At point S is S3, at point E is also E3, and at point N is equal to N1. Then in triangle OPN, it's OPN is O1, and P is the whole angle, N is equal to N2. It just makes it easier when I compare my angles to see if they are equal or not. Then we spoke about this expression. This one is a development from similar triangles. So I need to figure out which similar triangles were used to answer the question. Normally, when it's following from the previous question, start by checking the previous question first. It might be the one from where this expression is coming from. Then number 5.3, also here, this is definitely similarity. I need to find out which two triangles are similar that have been used to create this expression. And I can figure that out by looking at the number, the lines which are in this expression, P, E, O, E, and E, N. Once I figure out those similar triangles, I can prove that they are similar and create equivalent fractions by dividing corresponding sides. Then this one here is just general reasoning, but we explained that if the word hence is given, it means you are developing this expression from the previous relationships that have been used. So we've got PE squared, and we also have got PN squared from 5.22 and 5.3. Then the question can be answered. So it's very much vital, ladies and gentlemen, that when you're answering a geometry question, start by looking for hints in the question that can help you indicate the theorems that are applicable in that particular question. So yeah, that's about it. Have a look at the more questions that we have posted and just try to do the question before you carry on with the video so that you can check if you are able to answer those questions correctly. That's about it for now.